Now it is your turn to completely factor the polynomial 49t squared minus 126t plus 81. If you've not attempted this example on your own already, please return to your lecture notes and try this, and once you've attempted it, then return to the video to check your work. We want to factor 49t squared minus 126t plus 81. The first step in factoring any polynomial is to find a greatest common factor. When we look through this polynomial, I look at the first term and see 49t squared. I then look at the last term and see 81. Given that the first term has t squared and the last term has no t's, I recognize that there cannot be a variable component of the greatest common factor. Looking at the numerical components, we have 49 and 81. The factors of 49 are 1, 7, and 49. Of those three, the only one that divides into 81 evenly is 1. This gives us our greatest common factor of 1. Now I consider the fact that I have a trinomial. Given that the coefficient on the t squared is a 49, one option would be to use the AC method. To use the AC method, I would multiply the a value and the c value, or 49 and 81 in this case, and if I multiply 49 times 81, I get 3,969. I would then need to find a pair of numbers that multiplies to make 3,969 and adds to make negative 126. The problem with this is I don't know offhand the factors of 3,969, so I would like to use a different approach if possible. So I then turn my attention and notice 49t squared. 49 is a perfect square and so is t squared. So that first term itself is a perfect square. I could think of 49t squared as the quantity 7t squared. 81 is also a perfect square. It's the same thing as 9 squared. Because the first term is a perfect square and the last term is a perfect square, this gives me an indication that this entire trinomial might be a perfect square trinomial. But to verify that it is, I need to check that the middle term fits the 2ab pattern. So 2ab in this case would be 2 times 7t times 9. When I multiply 2 times 7, I get 14. 14 times 9 is 126. So this does check. 2 times 7t times 9 is 126t. Now something that has not been explicitly stated but is important, for this to be a perfect square trinomial, the last sign used in front of that 81 or that 9 squared must be addition. If it was not addition there, this could not be a perfect square trinomial. The sign on the middle term, that negative on the 126t, will play a role, but it does not determine whether this is or is not a perfect square trinomial. As a reminder, the general way we write a perfect square trinomial is a squared minus 2ab plus b squared, and we know this factors as the quantity a minus b squared. Going back to our trinomial that we're trying to factor, this tells us then 49t squared minus 126t plus 81 would have to factor as a 7t in the front of the binomial, a 9 in the back of the binomial, and because the original 126t, the middle term, was a negative, the sign in the middle of the binomial will also match and be a negative. So we'll have 7t minus 9 quantity squared. Again, we could have approached this from that AC method, but this is a situation where knowing the perfect square trinomial definitely has an advantage.